Hey guys, we're going to go through Chapter 4, Section 5, and Section 6, Test Review. So we're going over Descartes' rule, rational root theorem, factoring completely, complex zeros, complex polynomials, all the stuff we've been doing the past 2 weeks. So first up, problem number 1. Use Descartes' rule of signs to determine how many positive x-intercepts and negative x-intercepts the function can have. So, to find the positive zeros, to find the positive x-intercepts, we look at the signs and we see of the original function and we see how many of them change. So I go from negative to positive. So that's 1. Positive to negative, that's 2. Negative to positive, that's 3. So I will have 3 positive zeros, or I'll have 1 positive real zero. Why does it drop down by 2? It drops down by 2 because if these aren't real zeros, then we'll have complex zeros that come in pairs. So with negative zeros, I'm going to plug in a -1, so that changes my signs from any odd exponent, it will change sign. So that turns positive, then I go negative, then I go negative, then I go positive. So if I look at my signs, this is for f of -1. I have 1 sign change, 2 sign change. So I'll either have 2 negative zeros or I'll have 0 negative zeros. Next up, list all possible x-intercepts for the function. I want to know what are my p over q values. So what are all the factors of p, my last term, and then what are all my factors of q. So my factors of p are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 9, and plus or minus 18. Then my q values are plus or minus 1, plus or minus 3. So my list is all values p divided by q. So I have plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, 9, 18, plus 1 divided by 3, 1 divided by 3, plus or minus 2 divided by 3. Then I have 3 divided by 3, which is 1. I have 6 divided by 3, which is 2. I have 9 divided by 3, which is 3. And I have 18 divided by 3, which is 6. So my entire list of all the possible x-intercepts for this function are 1, 2, 3, 6, 9, 18, 1/3, 2/3, all plus or minus. Next up, given this function, is x minus 1 a factor? Show your work. So originally we said we can plug in that 0 to our function and see if it comes out 0. So if we plug in 1, we get 3 times 1 minus 1, 3 times 1 to the 5th minus 1 squared plus 2 times 1 plus 18. So you get 3 minus 1 plus 2 plus 18, which is 3 minus 1 is 2, 2 plus 2 plus 18. It's not going to be 0. We get f of 1 is 22. So x minus 1 is not a factor. And just as a heads up, if you don't use the remainder theorem to see if it's a factor or not, or the factor theorem, I should say, and you use synthetic division instead, be careful, because you'll write 1 on the outside, and we'll write 3 if it's what comes after x to the 5th, x to the 4th, which is 0, x to the 3rd, which is 0, x squared is -1, 2, and 18. If I don't have those extra 2 zeros, something is not going to work out. So if we did synthetic division, we get 3, 1 times 3 is 3, add, 3, add, 1 times 3 is 3, 1 is 2, 1 times 2 is 2, so that's 4, 1 times 4 is 4, so we have 22. That's not 0. Be careful with this, that you make sure you have all of these terms, because that's x to the fifth, that's x to the fourth, that's x to the third, x squared, x, and a number. Next up, factor this polynomial 2x to the fourth minus 19x cubed plus 57x squared minus 64x plus 20 completely. So let's start out with what we've been doing lately. The maximum number of zeros, 4. How many positive zeros? I have 1, 2, 3, 4. I have 4 positive zeros, or 2 positive zeros, or 0 positive zeros. So if I'm looking for negative zeros and I plug in a negative 1, I'm going to change the x cube, I'm going to change the x sign. So then I have positive, 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 positive. So I have 0 sign changes. So all of my zeros are going to be positive. So now I'm going to make my list, my p's, my q's. What are my factors of 20? Plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10, plus or minus 20. My q's, I have plus or minus 1 or plus or minus 2. So my list will be all of these plus 1/2. 2 divided by 2 is 1. 4 divided by 2 is 2. 5 divided by 2. 10 divided by 2 is 5. 20 divided by 2 is 10. So now I'm going to pick a number, and I want to get this x to the fourth down to something workable. So I'm going to say I want to choose 2. So I do my synthetic division. 2 on the outside, then 2, negative 19, 57, negative 64, 20. Bring down the 2, multiply, add. Multiply, add. 57 minus 30 is 27. Multiply is 54. That's negative 10. And then negative 20, 0. So what do I get? I know that x minus 2, so I have x minus 2 is my factor. I can test to see if x minus 2 works again. So I'm going to bring down the 2. 2 times 2 is 4. That's negative 11. Negative 11 is negative 22. 27 minus 22 is 5. That's 10, 0. So I have x minus 2 again is a 0. Then what am I left with? I have x minus 2, I have x minus 2, and I have 2x squared minus 11x plus 5. We can factor this last quadratic. What numbers multiply to be first times the last? So 2 times 5 is 10. What numbers multiply to be 10 that add to negative 11? So I have 2x, x, 5, 1, negative, negative. Let's double check. 2x times 5 is negative 10. Negative 1 times x is negative 1. So negative 10 plus negative 1 is negative 11. And the question asked me, factor completely. So these are all of my factors. Done and done. Next up, we have a question that says, find the polynomial of degree 4 with x-intercepts 1, negative 2, and negative 4i. Well, we automatically should know that if we have negative 4i, the other 0 is positive 4i. So I'm going to write these as factors. I'm going to take the zeros, write them as factors. So I have x minus 1. I have x plus 2. I have x minus 4i, x plus 4i. Now it says find the polynomial, so I'm going to do multiplication. Multiply the complex zeros first. I get x squared plus 16. If I multiply these two, I get x squared, positive 2, negative 1 is positive x. Negative 1 times 2 is negative 2. So to finish this, I'm going to multiply out again, just distribute each term. So I have x squared times x squared, x to the fourth. X squared times 16 is 16x squared. I have x times x squared, so that's x cubed. I have x times 16, that's 16x. I have negative 2 times x squared, so negative 2x squared. I have negative 2 times 16, negative 32. If I add all the like terms together, I get x to the fourth plus x cubed. 16 minus 2 is 14x squared plus 16x minus 32. That is the polynomial that has these as zeros. Let's get that in view so you guys can see. Moving on. Last two questions, 6 and 7. The only difference here is I'm asking, one, I say, given this equal to 0, find all real and imaginary zeros. So let's just take a moment and think, what are we supposed to do here? All right, so looking at this polynomial, I want to find all real and imaginary values for x. So the max number of zeros is 4. How many positive zeros? I have 1, 2, 3. So I'll either have 3 or I'll have 1. How many negative zeros? Well, that will be positive, that will be positive, that will be negative, that will be negative, that will be negative. So I have 1 sign change, so that means I'll have 1 negative 0. So now list out my p's and q's. So factors of 52. So that's 1 and 52. Then I have 2 and 26. Then I have 3 and 13. And then I have, does 4 go into 52? 4 goes into 52 how many times? Sorry, it's not 3, it's 4. 4 and 13. 5 doesn't go in, 6 doesn't go in, 7 doesn't go in, 8, 9, 10, 11, 12, 13. We get back here. What are my q's? Plus or minus 1, plus or minus 3. So I'm going to list out all my p's and q's. All my p over q's. So I have plus or minus 1, 2, 4, 13, 26, 52. Plus or minus 1 divided by 3, 2 divided by 3, 4 divided by 3, 13 divided by 3, 26 divided by 3, 52 divided by 3 is, let's see, no, we're going to write 52 divided by 3. So that's a lot of numbers to check. So this is where having a graphing calculator comes in handy. If you look at this graph presented here, where does this cross the x-axis? So it looks like to me we're going to have to look at -4 first. So let's divide this by -4. So I'm going to write 3, -1, -9, 159, negative 52. Bring down the 3, multiply, add. That's negative 13. Multiply. 4 times negative 13 is 52. Add, so that is 43. Negative 4 times 43 is 160 plus 12, so negative 172. So if I do 159 minus 172, I get negative 13. Negative 4 times negative 13 is positive 52. Those add to 0. So I need to find another 0. If I look at my graph, it looks like 1/3 is going to do it. So let's try it out. Bring the 3 down, multiply, add. Negative 1/3 times negative 12 is negative 4. Add 39. 1/3 times 39 is 13. So right now I have negative 4 is 1, 0, 1/3 is 1, 0, and I'm left with 3x squared minus 12x plus 39. Each one of these has a factor of 3. So I can factor a 3 out. So I have 3 times x squared minus 4x plus 13. So now it looks like I'm stuck. My zeros so far are x equals negative 4, x equals 1/3, and now I'm looking for the last two zeros. So I'm going to use the quadratic formula. So negative b plus or minus square root of b squared minus 4 times ac all over 2a. So negative b, so I have 4 plus or minus square root b squared, 16, minus 4 times 1 times 13 all over 2 times 1. So that means I have 4 plus or minus square root of 16 minus 52 all over 2. Well, let's think. 16 minus 52 is negative 36. So I have 4 plus or minus square root of negative 36 all over 2. We're almost done. Square root of negative 36, 6i. 4 plus or minus 6i over 2. Divided both these by 2, we get 2 plus or minus 3i. So our three zeros, if it's okay for me to write them up here, is x equals negative 4, x equals 1/3, x equals 2 plus 3i, x equals 2 minus 3i. If you wanted to write the plus or minus sign with these, be my guest. It all works out to be the same. So let's zoom out, give you a nice picture of all the work that was included for this problem. Last bit. We're almost there. How do I factor? I want the list of real and imaginary x-intercepts. So first, see if you can factor. X squared plus 2, x squared plus 25. And this is equal to 0. So how do I solve? Well, I have x squared equals negative 25 here, and x squared equals negative 2 here. So then, if I take the square root, whenever you take the square root, you have to remember to write plus or minus. So x equals plus or minus square root of negative 2. X equals plus or minus square root of negative 25. Now, simplifying the square root of negative 2, that means x equals plus or minus I root 2. X equals plus or minus 5i. There's your solutions. We are done with the practice test. Good luck. Remember to ask any questions tomorrow if you need help. All right, bye-bye.